Look here, the coefficient of x power 10 in ax square plus 1 by bx whole to the power of 11 is equal to x to the power of minus 10 and ax minus 1 by bx square whole to the power of 11 coefficient. How to create the relation between a and b? So, we need the formula ax to the power of p plus b by x to the power of q whole to the power of n. Expansion. Look here, both looks like in this formula. X power k coefficient in this. How we calculate is to find tr plus 1, and this is in tr plus 1th term, isn't it? Where r is equal to np minus k by p plus q, np minus k by p plus q. Okay, we use this formula to solve this problem. Okay, right in the come here. First one is ax square 1 by bx is there. I can write it as 1 by b by x whole to the power of 11. Here, look here. When you compare with the formula, here p is equal to 2, q is equal to 1, n is equal to 11, isn't it? Power, and k is x power 10 coefficient, no 10. So formula is r is equal to np minus k by p plus q is equal to 22. 11 into 2 is 22 minus 10 by 3. 1 plus 2, 3, isn't it? Is equal to 12 by 3, nothing but 4. Nothing but 4, right? So go from the formula tr plus 1, go for the formula tr plus 1 is equal to ncrx to the power of n minus r a to the power of r. 11c r is 4. ax square whole to the power of n minus r is 11 minus 4. b to the power of r is 1 by bx whole to the power of 4. So, ncrx to the power of n minus r a to the power of r formula. 11c4, simplify 11c4, a to the power of 11 minus 4 is 7. Write b as by b to the power of 4, isn't it? And then x to the power of 14, and then denominator is 4, 14 minus 4, right? So, x power 10 coefficient is required, therefore, x power 10 coefficient is equal to 11c4 a to the power of 7 by b to the power of 4. There is the first part of the problem. So, go for second part here, go for the second part. Look here, second part is how to find x power minus 10 coefficient in ax minus 1 by bx square whole to the power of 11. Isn't it? Here p is equal to 1, q is equal to 2, n is equal to 11, same power, and k is equal to power where it is here minus 10. So, k is minus 10. So, use the formula r is equal to np minus k by p plus q. Okay, where np is 11 minus of minus 10 plus 10 by 1 plus 2. So, 11 plus 10 is 21 by 3, 7, 1, 7, 3, right, 7, n is equal, r is equal to 7. So, tr plus 1 we have to calculate, which is 11c r is 7, a, that is ax whole to the power of 11 minus 7, and minus 1 by bx square whole to the power of 7. ncr x to the power of n minus r a to the power of 1. So, ncr is equal to ncn minus r, we know that. So, 11c 7 is 11c, 11 minus 7 is 4. Then a to the power of 4 I can write by simplification, and minus 1 by b to the power of 7 into x to the power of minus 10. So, I can write x power minus 10 coefficient is equal to 11, x power minus 10 coefficient is equal to 11c4 minus a to the power of 4 by b to the power of 7, right? So, is it clear up to now? Right. So, now we go to the actual problem. Look into the problem. Look into the problem. Here it is coefficient of x power 10 in this expansion is equal to coefficient of x power minus 10. So, equal these two things. Equate these two things. There is 11c4 a to the power of 7 by b to the power of 4 is equal to 11c4 minus a to the power of 4 minus by b to the power of 7. Okay. 11c4 gets cancelled. A power 7 minus a power 4 is a cube. No. Let us cross multiply and do it. It's better. I can take a power 7 into b power 7 directly. Then is equal to minus a power 4 b power 4. So gets cancelled. A cubed b cubed, that is ab whole cubed is equal to minus 1. ab is equal to minus 1, isn't it? So now we end here with an important result, ab plus 1 is equal to 0. Are you clear here? Right, an important problem. Is it clear? Right. It's a very easy problem. Try once. Thank you. Look here. 36, 84, 126 are successive binomial coefficients in the expansion of 1 plus x whole to the power of n. Then how to find n? What do we know is 1 plus x whole to the power of n expansion is nc naught to the power of n, no, nc naught plus nc1 into x plus nc2 into x square plus so on. Ncr minus 1 x to the power of r minus 1, ncr x to the power of r, ncr plus 1 x to the power of r plus 1, so on. Last term is ncn x to the power of n. So this is the expansion of 1 plus x whole to the power of n. When the successive binomial coefficients are given, successive binomial coefficients, let ncr minus 1 is equal to 36. ncr is equal to 84 and ncr plus 1 is 126. 126 ncr plus 1, ncr minus 1, ncr plus 1 are 36, 84, 126, isn't it? So ncr plus 1 I can write it as 126. Okay, right, look here. ncr minus 1 is 36, ncr is 84, ncr by ncr minus 1 is equal to 84 by 36. This is an equation number 1. We know formula as n minus r plus 1 by r formula. 12 3s, 12 7s, 7, isn't it? 7 by 3. Okay, right. 3n cross multiply 3n minus 3r plus 3 is equal to 7r, isn't it? 3n plus 3 is equal to 10r. That is equation number 1 already written, 2. Right. 1 and 2. Right. Next we go for the formula. ncr plus 1 by ncr. Divide into these two things. There is 126 by 84. Right. 84. Look here. 6 twos, 1s, 6 14s. Again 7 twos, 7 3s. Isn't it? So I can write it as 3 by 2. Right, the formula n minus r by r plus 1. Okay, and you know the formula, I think there is 3 by 2. You know formula very well. I write again, ncr is equal to ncr by ncr minus 1, isn't it? Is equal to n minus of kinda bhagani minus of r minus 1 by r adi rasa. Okay, that's formula I applied here. Okay, right, I think clear. Video is clear, I think, right. Cross multiply 2n minus 2r is equal to 3r plus 3. 10r on the gun. 2n minus 3 is equal to 5r. I can write it as 4n minus 6 is equal to 10r. This side we have 10R, so I multiplied with 2, 10R. This I consider this as equation number 3 equation, right? Compare these two things. So from 2 and 3, from 2 I consider this as 3, 2 and 3. You equate these two things, 3n plus 3 is equal to 4n minus 6. This and n side n is equal to 9. So that's the answer. I think it's very clear. Is it clear? Thank you. Another important problem here. If P and Q are sum of odd terms and even terms in the expansion of x plus a whole to the power of n, then we have to prove that first one x square minus a square is equal to this and 4pq is equal to this. So 4pq x p square minus q square are given. So p and q are sum of even and odd terms. Okay, expansion x plus a whole to the power of n expansion we know. We know that nc naught x to the power of n plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 into a square plus so on x cubed okay, so on ncn a to the power of n, isn't it? I consider this as a term, first term, second term, this as third term, this as fourth term, and so on. This is n plus 1th term, isn't it? Last it contains n plus 1 terms. X plus a whole to the power of n contains n plus 1. Sum of even terms, odd terms. P is sum of odd terms. Sum of odd terms. So I can write P. So P is equal to odd terms T1, T3, so on. So there is T1 plus T3 plus T5 plus so on, isn't it? So P can be written as nc naught x to the power of n, okay, right? nc1 x to the power of n minus 1 into a, nc4 x to the power of n minus 4 into a to the power of 4, all the even terms, even powers, so on, right? Similarly, so you can write q. What is q? Sum of even terms, isn't it? Sum of even terms. Even terms T1, T2, T4, so on, isn't it? So q is equal to nc1 x to the power of n minus 1 into a, nc3 x to the power of n minus 3 into a cube plus so on, isn't it? Now look here, P and Q are calculated with the help of that. So P plus Q, if you add it, you will get the same x plus a whole to the power of n. Again, simple one, right? X plus a whole to the power of n. What is P minus Q? First term minus first term. We have to separate these two things. P minus Q is nc naught x to the power of n minus nc1 x to the power of n minus 1 into a. Is it clear? Again, nc2 x to the power of n minus 2 into a square. We have to subtract in the q, that is nc3 x to the power of n minus 3 into a cube. So on. So there is nothing but we know the formula for P minus Q as x minus a whole to the power of n. Is it clear? So we calculate P plus Q and P minus Q from this, isn't it? This first part of the work completed. So with P plus Q, P minus Q, with P plus Q, P minus Q, these two things are important. See there, P square minus Q square is there, no? So for this you have to calculate. First one is P square minus Q square, which is equal to P plus Q into P minus Q. I can write it as P plus Q into P minus Q, isn't it? P minus Q. P plus Q, P minus Q. Right. So what is P plus Q? From this expansion, x plus a whole to the power of n. See here. Okay. And then P minus Q is x minus a whole to the power of n. Look here. There is x minus a whole to the power of n. There is x square minus a square whole to the power of n is the answer. First one is completed. So is it clear? Is it clear? We have to go for next one, 4pq. That is second one. What is 4pq? 4pq from lower studies we know. 4pq is p plus q whole square minus p minus q whole square. A minus b whole square minus a plus b whole square minus a minus b whole square is 4ab, right? There is p plus q whole square. Look at x plus a whole to the power of n whole square is x plus a whole to the power of 2 into n. 2 into n, 2 into n, 2 into n. So there is 2n minus x minus a whole to the power of 2n. Okay. So that is p for p. So that ends the second problem. Is it clear? Right. Complete this. It's another important problem given for 7 marks many times.